elements and p block elements. Hydrogen, it is the most abundant element in the universe. Which is the most abundant element in the universe? Hydrogen. The most abundant element in the earth crust is oxygen. ഭൂമിയുടെ ഉപരിതലത്തില് ഏറ്റവും കൂടുതലുള്ളത് oxygen. And 45% is oxygen. But the most abundant element in the universe, ഈ പ്രപഞ്ചത്തിൽ ഏറ്റവും കൂടുതലുള്ളത് സണ്ണില്, സ്റ്റാർസില് ഒക്കെ ഉള്ളത് ഹൈഡ്രജൻ ആണ്. ഇറ്റ് ഇസ് ദ ലൈറ്റസ്റ്റ് എലിമെന്റ്, ഏറ്റവും ഭാരം കുറഞ്ഞ എലിമെന്റ് ഹൈഡ്രജൻ ആണ്. ആൻഡ് ഹൈഡ്രജന് ഒരു പ്രോട്ടോൺ ന്യൂക്ലിയസിലുണ്ട്, ഒരു ഇലക്ട്രോൺ അതിന് ചുറ്റുമുണ്ട്. ഇതാണ് the most that is important isotope of hydrogen, hydrogen 1,1. But if there is one neutron also, it is hydrogen 1,2, deuterium, heavy hydrogen. And a third isotope is hydrogen 1,3, that is tritium. It is radioactive. Anyway, hydrogen can be prepared in the laboratory by treating a zinc with dilute sulfuric acid. Zinc plus H2SO4 gave zinc sulfate plus hydrogen. And that is the method of preparation of hydrogen in the laboratory. And any active metal, that is zinc plus H2SO4 dilute sulfuric acid gave zinc sulfate plus hydrogen. This is the laboratory method of preparation of hydrogen. And any active metals like that is alkali metals or alkaline earth metals, when treated with water, you will get hydrogen, sodium or potassium or calcium. They will react with water to give the hydrogen. That is another method of preparation of hydrogen. And hydrogen can be manufactured by passing steam over red hot coke or steam over hydrocarbon. When steam is passed over red hot coke, carbon plus H2O give a mixture of carbon monoxide and hydrogen. Carbon plus H2O gives CO plus H2. And this mixture is called water gas. And that is, water gas is also known as synthesis gas because we can prepare a large number of compounds, organic compounds, by using water gas. For example, methanol can be prepared from water gas, that is CO plus H2 water gas, and it can be converted into, that is by suitable method, CO plus 2H2 gives, that is CH3OH, methanol. Similarly, various compounds can be prepared from the water gas, and the water gas is also known as synthesis gas or syngas. Then another method of manufacture of, that is hydrogen, is Lane's process. And Lane's process is passing steam over red hot iron. That is, when steam is passed over red hot iron. Hello? No, mute it. Fe plus, that is 3Fe plus 4H2O gives Fe3O4 plus 4H2. And that is another method of manufacture of hydrogen. That process is called Lane's process. And the first question is about that. That is the first question, that is, which of the following can produce hydrogen from water? Answer is heated iron. Heated iron can produce, that is, hydrogen from water. Choice is B. Heated stannic oxide or heated aluminum oxide or heated copper oxide cannot produce hydrogen from water. But we can see that in the laboratory method of preparation, zinc plus sulfuric acid gave, that is hydrogen. And alkali metals and alkaline earth metals, when treated with water, gives hydrogen. And when steam is passed over red hot coke, or when it is passed over hydrocarbon, methane, ethane, propane, etc., it can produce hydrogen. As well as another method of manufacture of hydrogen is electrolysis of water. Usually water will not conduct electricity, therefore acidified water or basified water, it is electrolyzed, you will get hydrogen at the cathode. And these are the various method of manufacture of hydrogen. And here the question is, how will you produce? That is, hydrogen is heated ion. When that is, water is treated with heated ion. That process is called Lane's process. That is 3Fe plus 4H2O give Fe3O4 plus 4S2. And that is the method of manufacture of hydrogen. That process is called Lane's process. The second question is, why do calcium ions make water hard, but sodium ion do not? The most important compound of hydrogen is water. That is the most important compound of hydrogen is water, H2O. And water, it can be broadly classified into soft water and hard water. And it depends upon if the water give good lather with soap, it is known as soft water. If it will not give good lather with soap, it is hard water. Soap പതയുന്ന വെള്ളത്തിനെ നമ്മൾ സോഫ്റ്റ് വാട്ടർ എന്നും സോപ്പ് പതയാത്ത വെള്ളത്തിനെ നമ്മൾ ഹാർഡ് വാട്ടർ എന്ന് വിളിക്കുന്നു. That is the soft water and hard water. And what is the reason for the hardness of water? എന്തുകൊണ്ടാണ് ഹാർഡ് വാട്ടറിൽ സോപ്പ് പതയാത്തത്? And the reason is the dissolved calcium ions and magnesium ions in the water. വെള്ളത്തില് കാൽസ്യം അയോൺസും മെഗ്നീഷ്യം അയോൺസും ഉണ്ടെങ്കിൽ ആ വെള്ളമാണ് ഹാർഡ് വാട്ടർ എന്ന് പറയുന്നത്. ആ വെള്ളം സോപ്പ് പത തരില്ല. അപ്പൊ ലോണ്ടറി പർപ്പസിൽ നമുക്കത് ഉപയോഗിക്കാൻ കഴിയില്ല. And that is known as hard water. അപ്പൊ hard water, it is not unfit for drinking purpose, but it is unfit for laundry purpose. അലക്കാൻ ഉപയോഗിക്കാൻ കഴിയില്ല എന്നേ ഉള്ളൂ, കുടിക്കുന്നതുകൊണ്ട് കുഴപ്പമില്ല. Another disadvantage of hard water is boiler. That is, steam generators are called boiler. ഇപ്പൊ ഇൻഡസ്ട്രീസിലൊക്കെ സ്റ്റീം പ്രൊഡ്യൂസ് ചെയ്യുന്ന വലിയ ബോയിലേഴ്സിലാണ്. ആൻഡ് ബോയിലറിൽ ഹാർഡ് വാട്ടർ ഉപയോഗിച്ചാൽ ഇറ്റ് വിൽ ഫോം സ്കെയിൽസ്. ആ കാൽസ്യം സാൾട്ട് ഒക്കെ ഡെപ്പോസിറ്റ് ചെയ്തിട്ട് ആ ബോയിലറിന്റെ സൈഡിലെല്ലാം പറ്റി പിടിച്ചിട്ട് സ്കെയിൽസ് പ്രൊഡ്യൂസ് ചെയ്യും. അപ്പൊ ഒരുപാട് വേസ്റ്റേജ് ഓഫ് ഹീറ്റ് ഉണ്ടാവും. അതുപോലെ തന്നെ ആ ബോയിലർ ബേസ്റ്റ് ചെയ്യാനുള്ള സാധ്യതയും കൂടുതലാണ്. അപ്പം ദാറ്റ് ഈസ് ഹാർഡ് വാട്ടർ ഈസ് അൺഫിറ്റ് ഫോർ ഡ്രിങ്കിങ് പർപ്പസ് as well as it is unfit for boilers. And that is the only disadvantage of hard water. And the hardness of water is due to the dissolved calcium ions, Ca2 plus ions, and magnesium ion, Mg2 plus ions. The hard water or hardness of water can be broadly classified into temporary hardness and permanent hardness. A temporary hardness means that hardness can be removed by boiling. If the water is boiled, then it becomes soft water. And that is if it is temporary hardness. And the temporary hardness is caused by the dissolved bicarbonates of calcium and magnesium. CaHCO3. Calcium bicarbonate is CaHCO3. On boiling, calcium bicarbonate decomposed to give calcium carbonate, which is insoluble in water, and therefore dissolved calcium ions are removed. Similarly, magnesium bicarbonate on boiling, it will decompose to give magnesium hydroxide, and thereby it is insoluble in water, and thereby it is removed. And that is the bicarbonates of calcium and CaHCO3 twice on heating decompose to give CaCO3 plus H2O plus CO2. That is, carbon dioxide gas is lost and calcium bicarbonate become calcium carbonate, and calcium carbonate is insoluble in water, and the dissolved calcium ions and magnesium ions are removed and the water becomes soft water, and that is temporary hardness of water. But if there is chlorides and sulfates of calcium, if it is present in the water, it causes the permanent hardness. That is, permanent hardness is caused by the chlorides and sulfates of calcium and magnesium. Calcium chloride, CaCl2, or magnesium chloride, MgCl2, or calcium sulfate, CaSO4, or magnesium sulfate, MgSO4. If they are dissolved in water, it causes the permanent hardness. And the permanent hardness cannot be removed by simply boiling. The boiling water, even if you boil it, it will not remove the hardness, and that is known as permanent hardness. And the removal of permanent hardness can be carried by adding sodium carbonate. Sodium carbonate is washing soda. When you add sodium carbonate, the calcium chloride or magnesium chloride react with, that is sodium carbonate, Na2CO3, to give CaCO3 plus 2NaCl. That is, calcium ions are get precipitated as calcium carbonate, or magnesium ions are get precipitated as magnesium carbonate, which is insoluble in water, and thereby the hardness is removed. And that is another method of removal of hardness in the case of permanent hardness. And temporary hardness can be also removed by adding Slakert lime. What do you mean by Slakert lime? Calcium hydroxide, CaOH twice. That is, calcium bicarbonate plus calcium hydroxide give calcium carbonate plus carbon dioxide plus water. That is, temporary hardness can be removed by simply boiling or by adding Slakert lime, calcium hydroxide. And since it is water, instead of Slakert lime, we can add quicklime also. Calcium oxide can be also added. Calcium oxide will react with water to give calcium hydroxide, which will react with, that is, calcium bicarbonate or magnesium bicarbonate to give the undissolved calcium carbonate or magnesium carbonate. And that is a temporary hardness can be removed by either boiling or by adding Slakert lime or quicklime. That process is called Clark's process. And there are another methods of removal of, that is, the permanent hardness by various other methods. The permutate method, that is sodium hexametaphosphate is added, or by using ion exchange resins, etc. Anyway, the second question is, why do calcium ions make water hard but sodium ions do not? That is, soap is nothing but the sodium or potassium salt of higher fatty acid, that is stearic acid, palmitic acid, etc. And stearic acid is C17H35COOH. Therefore, sodium stearate means it is C17H35COONA. This is sodium stearate. And when soap is added to water, it will decompose to give the stearate ion, C17H35COO minus plus Na plus. And this C17H35COO minus, and there is a hydrophobic carbon chain and hydrophilic carboxylate N, and they will form an associated colloid when the concentration increases, and the cleansing action of soaps and detergent, or the foam is formed, or the soap set is formed by the stearate ion forming colloidal size particle. And when the hard water is used, the calcium ions and magnesium ions, they will combine with stearate ion to give calcium stearate, and thereby it will get precipitated as calcium stearate. That is, all the stearate ions are get precipitated as calcium stearate, and thereby the associated colloid or micelles are not formed, and thereby it cannot use for cleansing purpose. That is why hard water is unfit for laundry purpose. Then why sodium cannot be used? Sodium stearate, it is soap. Soap is sodium stearate, and it will dissociate to give the stearate ion and the sodium ion. That is why, that is, the hard water will not give a good lather with soap. And here, why do calcium ions make water hard, but sodium ion does not? Answer is, calcium forms insoluble compounds with stearate ion present in the soap. Choice is A. And that is why if you use hard water, the soap will get precipitated. All the soap will get precipitated. Therefore, high wastage of soap. They will precipitate as calcium stearate or magnesium stearate. The third question is, a commercial sample of hydrogen peroxide marked as 100 volume hydrogen peroxide means hydrogen peroxide H2O2. It is having various concentration terms like volume strength, percentage strength, normality, molarity, etc. And usually the strength of hydrogen peroxide is expressed as volume strength. And the volume strength of hydrogen peroxide is nothing but hydrogen peroxide on decomposition, 2H2O2. On decomposition give 2H2O plus O2. That is, oxygen gas is liberated by the decomposition of hydrogen peroxide. Hydrogen peroxide on decomposition give oxygen gas. And therefore, that is, what is the amount of oxygen liberated at STP? And that is the volume of oxygen liberated at STP by the decomposition of 1 ml of hydrogen peroxide is known as its volume strength. That is, volume strength of hydrogen peroxide is number of milliliter of oxygen liberated at STP by 1 ml of the given hydrogen peroxide. If 1 ml of an hydrogen peroxide decomposed to give 10 ml of oxygen at STP, it is 10 volume hydrogen peroxide. If 1 ml of an hydrogen peroxide liberate 30 ml of oxygen at STP, it is 30 volume hydrogen peroxide. That means volume strength of hydrogen peroxide is number of milliliter of oxygen liberated at STP by the decomposition of 1 ml of hydrogen peroxide at STP. And that is known as volume strength. Or otherwise we can say that it is the volume in liter, volume of liter of oxygen liberated at STP by the decomposition of 1 liter of that hydrogen peroxide. That can be also defined as volume strength. 1 ml 10 ml oxygen liberate cheyanengil 1 liter 10 liter oxygen liberate, and that is called the volume strength. That is, usually the volume strength of hydrogen peroxide is expressed as, that is, the number of milliliter of oxygen liberated at STP by the decomposition of 1 ml of that hydrogen peroxide, or number of liter of oxygen liberated at STP by the decomposition of 1 liter of that hydrogen peroxide at STP. That is known as volume strength. Then percentage strength is there. Percentage strength is the volume of, it is the percentage of hydrogen peroxide present in 100 ml of that hydrogen peroxide. And we know that, that is, the equation is 2H2O2 give 2H2O plus O2 means 2 mole of hydrogen peroxide. 2 mole of hydrogen peroxide means it is hydrogen peroxide, the molecular mass is 34, and 2 moles of hydrogen peroxide means 68 gram hydrogen peroxide. On decomposition give 1 mole of oxygen at STP, that is 22,400 ml of oxygen at STP. 1 mole of any gas at STP occupies 22,400 ml. Therefore, what is the weight of hydrogen peroxide which on decomposition give 1 ml of oxygen at STP? It is 68 by 22,400. This is the weight of hydrogen peroxide which will produce 1 ml of oxygen at STP. If the volume strength is X, then what is the weight of hydrogen peroxide that will produce X ml of oxygen at STP? It is 68 into X by 22,400. And this is the volume of hydrogen, which is a weight of hydrogen peroxide in 1 ml of that. Therefore, in 100 ml, it is into 100. And that is the percentage strength. And the percentage strength is 68 by 224 into volume strength. Approximately, it is 0.3. It is 67.2 on it, but we can take it as approximately 0.3. And therefore, percentage strength is equal to 0.3 into volume strength. Therefore, whenever you get a question like that, you can do approximation. That is, a 10 volume hydrogen peroxide means 0.3 into 10. It is 3% hydrogen peroxide. A 20 volume hydrogen peroxide means 0.3 into 20, that is 6% hydrogen peroxide. There may be slight variation. It may be 6.02 like that. And a 30 volume hydrogen peroxide means it is 10% likewise. And that is the way in which we can calculate the percentage strength. The normality means it is a number of equivalents of, that is, therefore, the volume strength into percentage strength into 10 will give the weight per liter. Percentage strength into 10 will give weight per liter divided by, that is, equivalent weight 17. Therefore, percentage strength into 10 by 17 will give normality, or volume strength into, that is 68 by 224 into 10 by 68 by 224 into 10 by 17 will give normality. Molarity is equal to percentage strength into 10 by 34. That is the normality of hydrogen peroxide is twice its molarity, or molarity of hydrogen peroxide is half of its normality, because hydrogen peroxide is a dibasic acid. And usually the molarity and normality are related as normality is equal to molarity into basicity of an acid. And therefore, normality of hydrogen peroxide is molarity into 2, because it is a dibasic acid. And anyway, that is, now the question is, that is, a commercial sample of hydrogen peroxide marked as 100 volume hydrogen peroxide means, what do you mean by 100 volume hydrogen peroxide? 1 ml of that hydrogen peroxide will give 100 ml of oxygen at ST. Therefore, the choice is A. And what is the percentage strength of that hydrogen peroxide? It is 30% hydrogen peroxide. 0.3 into 100, that is, it is 30% hydrogen peroxide. And it is also known as perhydrol. Hydrogen peroxide is also known as perhydrol. The fourth question is, in which of the following reactions H2O2 is acting as a reducing agent? Hydrogen peroxide. In hydrogen peroxide, oxygen is in the -1 oxidation state. In the last class, we have discussed the oxidation number of all elements and the oxidation number of oxygen in usual oxide. It is -2. In water, it is -2. In peroxide, it is -1. In superoxide, it is -half. And in, that is, OF2, it is +2. Yesterday, we have mentioned. Anyway, that is, in hydrogen peroxide, the oxidation number of oxygen is -1. And if the oxidation number of oxygen in hydrogen peroxide increases to, that is, 0, from -1 to 0, that means increase in oxidation number. Increase in oxidation number is oxidation. Increase in oxidation number is oxidation. When it is oxidized, it acts as a reducing agent. It acts as a reducing agent. Therefore, hydrogen peroxide can act as a reducing agent when the oxidation number of, that is, -1 increases to 0. Increase in oxidation number is oxidation. And when it is oxidized, it acts as a reducing agent. Therefore, whenever hydrogen peroxide reacts and it is converted into oxygen, that it is, oxygen is liberated during its reaction, it acts as a reducing agent. But when hydrogen peroxide is converted to water, the oxidation number of oxygen becomes -2. That is, from -1, it decreases to -2. That means it is being get reduced. Decrease in the oxidation number is reduction. And when it is reduced, it acts as a oxidizing agent. So hydrogen peroxide can act as an oxidizing agent as well as it can act as a reducing agent. And whenever it acts as an oxidizing agent, itself being get reduced and it become water. About reaction a product hydrogen peroxide water ആയിട്ട് മാറുന്നുവെങ്കിൽ it acts as a oxidizing agent. അതേസമയം hydrogen peroxide reaction നടന്നിട്ട് ആ പ്രോഡക്റ്റിൽ ഓക്സിജനെ ലിബറേറ്റ് ചെയ്യുന്നെങ്കിൽ it acts as a reducing agent. And that is the way in which we can find out whether hydrogen peroxide can act as an oxidizing agent or reducing agent. എന്തുകൊണ്ട് hydrogen peroxide oxidizing agent reducing agent ആയിട്ട് ആക്ട് ചെയ്യാൻ കഴിയുന്നത്? Because its oxidation number is -1 oxygen. It can increase to 0 or it can decrease to -2. That is why it can act as both oxidizing agent and reducing agent. Other acid medium alkaline medium. Hydrogen peroxide can act as an oxidizing agent in acid medium as well as in alkaline medium. It can also act as a reducing agent in both acid medium and that is that in the case of alkaline medium. And that about its oxidizing and reducing property. ഇതുപോലെ നമുക്ക് ഏതിന്റെയും കണ്ടുപിടിക്കാൻ കഴിയും. That is ഒരു കോമ്പൗണ്ടിന് ഇപ്പൊ ഹൈഡ്രജൻ സൾഫൈഡ് എടുത്താൽ സൾഫറിന്റെ ഓക്സിഡേഷൻ നമ്പർ -2 അത് ഫർദർ ആയിട്ട് ഡിക്രീസ് ചെയ്യാൻ കഴിയില്ല. പക്ഷെ it can increase up to +2, +4, +6. Therefore hydrogen sulfide can get oxidized. That means it is a very good reducing agent. It is a very good reducing agent. But if you take that is sulfuric acid, H2SO4, sulfur is in the +6 oxidation state. The maximum oxidation state of sulfur is +6. It cannot increase further. That means it cannot get oxidized further, but it can decrease, and therefore it can act as a, that itself can get ready. It can get decreased means it can get reduced. That means it can act as a oxidizing agent. Sulfuric acid can only act as a oxidizing agent, but it cannot act as a reducing agent. Whereas hydrogen sulfide can act as a only as a reducing agent. It cannot act as a oxidizing agent. But if you take sulfur dioxide, SO2 or SO3, that is SO2, it is +4 oxidation state. It can decrease up to -2. It can increase up to +6. And therefore SO2 can act as both oxidizing agent and a reducing agent. But SO3, it is maximum +6. It cannot act as a reducing agent. It can only act as a oxidizing agent. That is if a substance can act as oxidizing agent or reducing agent. Potassium permanganate, K1O4, manganese is in the +7 oxidation state. It cannot increase its oxidation number, and therefore it can only act as a oxidizing agent. It cannot act as a reducing agent. Anyway, here the question is, in which one of the following reaction H2O2 is acting as a reducing agent? That is PbS plus 4H2O2 gave PbSO4 plus 4H2O. That is hydrogen peroxide water ആയിട്ട് മാറുന്നു. Hydrogen peroxide water ആയിട്ട് മാറുക എന്ന് വെച്ചാൽ itself act as a അത് reduce ചെയ്യപ്പെടുക ചെയ്തേ. Therefore it act as a oxidizing agent. In which of the following reaction H2O2 is acting as a reducing agent എന്നാണ് question. A choice ഇത് oxidizing agent ആണ്. അത് മാത്രമല്ല reaction ഒരു importance ഉണ്ട്. PbS is black. That is lead painting എല്ലാം lead ഉണ്ടാവും. അത് അന്തരീക്ഷത്തിൽ ഇരുന്ന് കഴിഞ്ഞാൽ അന്തരീക്ഷത്തിലെ സൾഫറുമായിട്ട് റിയാക്ട് ചെയ്തിട്ട് lead sulfide ബ്ലാക്കൻ ചെയ്തു പോകും. അത് ബ്ലാക്കൻ ചെയ്ത lead sulfideനെ നമുക്ക് white lead sulfate ആക്കി മാറ്റാൻ ഹൈഡ്രജൻ പെറോക്സൈഡിന് കഴിവുണ്ട്. അത് lead sulfideനെ ഓക്സിഡൈസ് ചെയ്താണ് ആക്കുന്നത്. And that is the bleaching agent ആയിട്ടും that is hydrogen peroxide act ചെയ്യാൻ കഴിയും. That is black lead sulfate is converted into white lead sulfate. Oil painting in one of the use of hydrogen peroxide, oil painting ഒക്കെ കുറെ നാൾ കഴിഞ്ഞ് ബ്ലാക്കൻ ചെയ്താൽ അത് മാറ്റാനായിട്ട് hydrogen sulfide ഉപയോഗിക്കാം. Another is 1 liter, that is 2K plus H2O2 give 2KOH plus I2. Potassium iodide iodide ion ആണുള്ളത്, K plus and I minus. അത് I2 ആയിട്ട് മാറുന്നു. അപ്പൊ -1 നിന്ന് 0 ആയിട്ട് മാറുന്നു. അത് ഓക്സിഡൈസ് ചെയ്യപ്പെടുക ചെയ്യാം. അപ്പൊ ഓക്സിഡേഷൻ ആണ് നടക്കുക. ഹൈഡ്രജൻ പെറോക്സൈഡ് പൊട്ടാസ്യം ഹൈഡ്രോക്സൈഡ് ആയി -2 ആയി ഓക്സിജന്റെ. Therefore, it is also oxidation reaction. H2O2 plus SO2 give H2SO4. അവിടെ സൾഫറിന്റെ +4 in +6 ആയി. That is sulfur dioxide is being get oxidized, and sulfur dioxide act as a reducing agent and hydrogen peroxide act as a oxidizing agent. That is oxygen -1 in -2 ആയിട്ട് മാറി H2SO4 ല്. അപ്പൊ A, B, C, it is choices in which hydrogen peroxide act as a oxidizing agent. But in D choice, Ag2O plus H2O2 gave 2Ag plus H2O plus O2. അവിടെ hydrogen peroxide oxygen ആയിട്ട് മാറുന്നു. Oxygen ആയിട്ട് മാറുമ്പോ -1 in 0 ആകുന്നു. It is increasing its oxidation number. It is being get oxidized. That means it acts as a reducing agent. It removes oxygen from silver oxide to give silver. Ag2O silver +1 oxidation state ആണ്. Silver it is 0 oxidation state ആണ്. Ag2O is get oxidized to, that is Ag2O is get reduced to Ag, and that is hydrogen peroxide act as a reducing agent. Our choice D is the correct answer. Which of the following on oxidation gives H2O2? Hydrogen peroxide method of preparation. One, that is hydrogen peroxide can be prepared in the laboratory by treating any peroxide with dilute acid. For sodium peroxide, Na2O2 plus H2SO4 gave Na2SO4 plus H2O2. And the best method is to prepare hydrogen peroxide in the laboratory is by treating barium peroxide. Barium peroxide, when treated with, that is BaO2 plus H2SO4 gives barium sulfate, BaSO4 plus H2O2. Actually, octahydrated form of barium peroxide is treated with dilute sulfuric acid to give hydrogen peroxide. This is the laboratory method of preparation of hydrogen peroxide. And the manufacture of hydrogen peroxide, it is by the auto-oxidation of, that is 2-ethyl anthraquinol. 2-ethyl anthraquinol. Anthracene is having 3 benzene ring, and anthraquinol, this is anthraquinol. This is anthraquinol and 2-ethyl anthraquinol. This is 2-ethyl anthraquinol. And that on, that is oxidation, air oxidation. That on air oxidation, that is 2 hydrogen atom, oxygen kuda chernittu 2-ethyl anthraquinone. 2-ethyl anthraquinone. Quinol is dihydroxy derivative and other diketone derivative aayittu marunnu. 2-ethyl anthraquinone plus H2O2. This is the method of manufacture of hydrogen peroxide. 2-ethyl anthraquinol on air oxidation is converted into 2-ethyl anthraquinone and hydrogen peroxide. This 2-ethyl anthraquinone on reduction with hydrogen, it is again converted to 2-ethyl anthraquinol, and again that on air oxidation gave 2-ethyl anthraquinone and hydrogen peroxide. Actually, hydrogen peroxide is manufactured from hydrogen and oxygen. That is, it is a easy method of manufacture of hydrogen peroxide because on air oxidation, 2-ethyl anthraquinol give 2-ethyl anthraquinone and hydrogen peroxide, and 2-ethyl anthraquinone on reduction with hydrogen gives the 2-ethyl anthraquinone, and that one again air oxidation give 2-ethyl anthraquinone and hydrogen peroxide. And that is the method of manufacture of hydrogen peroxide. Which of the following on oxidation give hydrogen peroxide is 2-ethyl anthraquinone? Choice is A. Temporary hardness and permanent hardness can be removed respectively by the addition of. I have already discussed the temporary hardness and permanent hardness. The temporary hardness is due to the bicarbonates of calcium and magnesium. It can be removed by simply boiling or by adding slaked lime or by adding quicklime. Calcium oxide, quicklime. Calcium oxide can remove temporary hardness. And the permanent hardness is due to the dissolved chlorides and sulfates of calcium and magnesium. It can be that is softened by adding washing soda, that is sodium carbonate, Na2CO3. Choice is calcium oxide and sodium carbonate. Choice is B. The oxide that gives hydrogen peroxide on treatment with dilute acid. We have already mentioned that hydrogen peroxide can be prepared by any peroxide when treated with dilute acid. That is sodium peroxide, Na2O2 plus H2SO4 give Na2SO4 plus H2O2. Here the answer is Na2O2. One more thing is, how can you identify an oxide, whether it is normal oxide or peroxide or superoxide, etc.? That is by looking into the oxidation number. By looking into the oxidation number, we can say that is BaO or calcium oxide, CaO, barium oxide, calcium oxide. Calcium, it is alkaline earth metal, barium, it is alkaline earth metal, and therefore oxygen is in the -2 oxidation state, and they are, that is normal oxides. And in the case of barium peroxide, BaO2, barium is in the +2 oxidation state, and therefore 2 oxygen atoms are in the -2 oxidation state. Oxygen is in the -1 oxidation state. That is why BaO2 is barium peroxide. Similarly, what about carbon? That is group 14, carbon dioxide. Carbon is in the +4 oxidation state. Oxygen is in the -2 oxidation state. It is the normal oxide. But in the case of PbO2, lead is also in the +4 oxidation state, and therefore oxygen is in the -2 oxidation state. It is also normal oxide. That is, BaO2 is barium peroxide, but PbO2 is lead dioxide. Carbon dioxide in the lead dioxide. They are the normal oxide. They are not peroxide. Choice A choice PbO2. PbO2 is lead dioxide, the normal oxide. MnO2, manganese in the +4 oxidation state. Manganese dioxide, MnO2. TiO2, titanium is the +4 oxidation state, titanium dioxide. They are all normal oxide. As there are 2 oxygen atom or oxide atom, they are called dioxide. But what about Na2O2? It is not sodium dioxide, it is sodium peroxide, because it is oxygen is in the -1 oxidation state. Sodium is +1 always, 2 sodium atom +2, 2 oxygen atom -2, oxygen is in the -1 oxidation state. Remember, we can find out whether it is a normal oxide or peroxide or superoxide or whatever be the oxidation number will change. Remember that. The 8th question is, metal hydrates are ionic, covalent or molecular in nature. That is, hydrogen can combine with metals, non-metals, as well as with metalloids, etc. Hydrogen, the first element, it can combine with active metals like lithium, sodium, potassium, other is alkali metals or alkaline earth metals, beryllium, magnesium, calcium, strontium, etc. And these metal hydrides, they are ionic in nature. They are ionic in nature. Alkali metal hydrides and alkaline earth metal hydrides are ionic in nature. But the hydrides of, that is P block elements, the boron hydrides, diborate, B2H6, as well as the hydrates of carbon family, CH4, C2H6, and the hydrates of nitrogen family, ammonia, phosphine, and the hydrates of oxygen family, water, that is like hydrogen sulfide, or the hydrates of halogen family, HFHCl, etc. They are all covalent in nature. Our hydrates can be classified into ionic hydride, and the ionic hydride is formed by alkali metals and alkaline earth metals, and covalent hydrates are formed by P block elements, group 13 to group 17. They are called covalent hydride, and there is interstitial hydride, and the interstitial hydride is formed by the D block and F block elements, and they are non-stoichiometric hydride because the hydrogen atom is occluded in the vacant voids of these metals, and they are called interstitial hydride. So, for hydrates can be broadly classified into ionic hydride, covalent hydride, as well as interstitial hydride. And here it is lithium hydride, sodium hydride, potassium hydride, rubidium hydride, that is they are ionic hydride. And the question is, that is the correct order of increasing ionic character. When the metal ion, the size increases, the size of the cation increases, the ionic character also increases because its polarizing power decreases, thereby the ionic character increases. Down in the group, the size increases and thereby the ionic character increases down in the group. Therefore, lithium hydride is least ionic, and cesium hydride, lithium, sodium, potassium, rubidium, and cesium. And that is the order of ionic hydride, the ionic nature of hydride. And therefore, here the answer is B. Lithium hydride less than, sodium hydride less than, potassium hydride less than, rubidium hydride less than, cesium hydride. And that about the ionic nature. The ninth question is, hydrogen resembles halogen in many respects, for which one several factors are responsible. Of the following factors, which one is most important in this respect? That is hydrogen. The position of hydrogen in the periodic table is not yet settled. That is, hydrogen, it is having only one proton in the nucleus. Its atomic number is 1, and therefore it is the first number, and actually it is having one electron in the 1s orbital, and therefore can be above, that is lithium in the alkali metals, the first group element, lithium, sodium, potassium, rubidium, cesium, etc. But that is, it will deviate from most of the properties, it will deviate from the alkali metals. It is having resemblance with alkali metals as well as it will deviate from alkali metals. The resemblance is its electronic configuration is 1s1, lithium in the valency shell electronic on 2s1, sodium 3s1. That is the valency shell electronic configuration of hydrogen resembles that of alkali metals. And similarly, it can form hydrogen ion, H plus ion, like alkali metals. Alkali metals form Li plus, Na plus, etc. Just like alkali metals, it can form, that is unipositive ions, H plus ion. But the ionization enthalpy or ionization potential of hydrogen is very high. Alkali metals are having very low ionization enthalpy, but the ionization enthalpy of hydrogen is very high. That means it is deviating from the behavior of alkali metals. And alkali metals can combine with halogens to give ionic halide, that is lithium chloride, sodium chloride, potassium chloride, etc. Hydrogen can also combine with halogens to give HF, HCl, HBr, etc. But that is, They are not ionic as in the case of that is alkali metal halides, and that is HF, HCl, etc. are more covalent in nature. And another resemblance is another deviation is alkali metals are solids, but hydrogen is a gas, and it is a diatomic gas. And therefore, in certain respect, it resembles that of halogens in the group 17, fluorine, chlorine, bromine, iodine, etc. Because the electronic configuration of fluorine is 1s2, 2s2, 2p5. And if it gains one electron, it becomes F minus. It is having the electronic configuration of next inert gas, neon. All the halogens, if it gains one electron, it can become the electronic configuration of inert gas of F minus or Cl minus, Br minus, I minus. They are having the electronic configuration of the next the inert gas. Similarly, hydrogen, if it accepts an electron H minus, it is having the electronic configuration of helium 1s2. That is, it resembles that of halogens. Just like halogen, it is also in short of one electron to attain the stable electronic configuration of the inert gas. Another resemblance with halogen is hydrogen is a diatomic gas. All the halogens are also diatomic, and fluorine is a gas, chlorine is a gas, bromine is a liquid, iodine is a solid. That is down in the group, the gradation in property. Just like fluorine and chlorine, hydrogen is a gas and it is a diatomic gas. And these are the resemblance. As well as the ionization enthalpy of hydrogen is almost similar to that of halogens. That is, they are also having very high ionization enthalpy, and hydrogen is also having high ionization enthalpy. And these are the resemblance of hydrogen with alkali metals as well as with halogens. And therefore, it may have, it is actually in, that is, the position of hydrogen is not yet settled, and that is the nature of hydrogen. And here it is asked is, hydrogen resembles halogens in many respects, for which several factors are responsible. Of the following factors, which one is most important in this respect? A, its tendency to lose an electron to form a cation. It is a resemblance with alkali metals. B, its tendency to gain a single electron in its valency shell to attain stable electronic configuration. It is a resemblance with halogens. That is, the answer is B. Question number 9, the answer is B. Which of the following equations depict the oxidizing nature of H2O2? I already mentioned that whenever hydrogen peroxide acts as an oxidizing agent, itself being reduced, and its oxidation number decreases from -1 to -2, that it becomes water. And therefore the choice is C. Iodide ion, it get oxidized in acid medium to give iodine. In all other choices, it acts as a reducing agent because it is converted to oxygen. Its oxidation number get increased, and that means it is acting as a reducing agent. And therefore the answer is C. Which of the following reactions is an example of use of water gas in the synthesis of other compounds? Water gas is a mixture of carbon monoxide and hydrogen. It is also called synthesis gas or syn gas, as it can be used to prepare a large number of compounds, and methanol can be prepared from that is water gas, and carbon monoxide plus 2s2 give in presence of cobalt catalyst give methanol, CH3OH, and that is the answer is D. Match column 1 and column 2 for the given properties, applications mentioned therein, and choose the correct option. Column 1 is hydrogen, atomic hydrogen, hydrogen molecule, dihydrogen molecule, water, hydrogen peroxide. Column 2 will A, used in the name of perhydrol. Perhydrol is hydrogen peroxide. About 4 is A. About 4A ആയിട്ടുള്ള ചോയ്സ് എയും സിയും ഡിയും ഉണ്ട്. നമുക്ക് അത് മാത്രം വെച്ച് കിട്ടുന്നില്ല. പിന്നെ വാട്ടർ H2O, third choice water and water can be used in water and edukumbothekkum fourth that is fifth third can be used, that is can be reduced to dihydrogen by sodium hydride. Water sodium hydride kude hydrogen produce ചെയ്യും. അപ്പോൾ that is water is reduced to hydrogen by sodium hydrate. അപ്പോൾ ആൻസർ ബി ആണ്. അപ്പോൾ ബി ചോയ്സ് ഉള്ളത് സിയിൽ മാത്രമേ ഉള്ളൂ അല്ലേ? 3B എന്നുള്ളത് സിയിൽ മാത്രമേ ഉള്ളൂ. ബാക്കി രണ്ടെണ്ണം കൂടി നോക്കാം. That is S2. S2 can be used in the hydro formulation of olefins. Olefins are, that is alkenes and alkynes. അതിനെ hydro formulation ഉപയോഗിക്കാനായിട്ട് hydrogen can be used. In hydrogen atom can be used, that is എവിടെയാ atomic hydrogen is used എവിടെയാ can be used in cutting and welding. അപ്പൊ 1 D ആണ്, 2 that is C ആണ്, 3 B ആണ്, 4 A ആണ്. ചോയ്സ് C ആണ്. And that about the answer is C. The 13th question is, a compound X of boron react with ammonia on heating to give another compound Y, which is called inorganic benzene. And the inorganic benzene B3N3H6. Inorganic benzene is B3N3H6. Actually, it is having the structure similar to that of benzene. അതുകൊണ്ടാണ് it is known as inorganic benzene എന്ന് പറയുന്നത്. That is BN ഇതാണ്, that is inorganic benzene. And H ഇതാണ് B3N3H6 inorganic benzene. And this inorganic benzene is formed, that is X when react with ammonia gives the inorganic benzene, that is Y. Y is called inorganic benzene. അപ്പോൾ B3N3H6 ആണ് Y. അപ്പോൾ ഏതാണ് X എന്നാണ് ചോദ്യം അല്ലേ? That is diborane B2H6 when treated with ammonia. Diborane ammonia treat ചെയ്യുമ്പോൾ diborane എന്താ B2H6, that is 2B2H6 plus ammonia NS3. എത്ര 3NS3 give B, that is 2B2H6 plus 6NS3. 6NS3 gives 3B2H6. 3B2H6 plus 6NS3 gives 2B3N3H6. Diborane when treated with ammonia gives inorganic benzene. അപ്പോൾ X എന്ന് പറയുന്ന diborane ആണ് and Y എന്ന് പറയുന്നത് inorganic benzene B3N3H6 ആണ്. ചോയ്സ് A ആണ്. ഡ്രൈ ഐസ് എന്ന് പറയുന്നത് സോളിഡ് കാർബൺ ഡൈ ഓക്സൈഡ് ആണ്. സോളിഡ് കാർബൺ ഡൈ ഓക്സൈഡ് is known as dry ice. In the structure of diborane, diborane സ്ട്രക്ചർ വളരെ ഇമ്പോർട്ടന്റ് ആണ്. 2 ബോറോൺ ആറ്റവും 4 ഹൈഡ്രജൻ ആറ്റവും ഒരു പ്ലെയിനില്, ഒരു ഹൈഡ്രജൻ ആറ്റം മുകളില്, ഒരു ഹൈഡ്രജൻ ആറ്റം താഴെ. They are bridged bond and that is the structure of diborane. അപ്പോൾ 2 boron atoms and 4 terminal hydrogen atoms lie in the same plane and 2 bridging hydrogen atoms lie in the perpendicular plane. Choice B on. The stable bivalency of lead and trivalency of bismuth is heavier p block elements. P block elements in the electronic configuration NS2 NP1 to NP6 ആണ്. boron family NS2 NP1 ആണ്. boron, aluminum, gallium, indium and thallium. And the സാധാരണ valency 3 ആണ് and oxidation state +3 ആണ്. അതുപോലെ കാർബൺ, സിലിക്കൺ, ജർമാനിയം, ടിൻ ആൻഡ് ലെഡ് വാലൻസി 4 ആണ്. പക്ഷെ ഹെവിയർ പി ബ്ലോക്ക് എലിമെന്റ്സില്, ദാറ്റ് ഈസ് 5th പീരീഡിലും 6th പീരീഡിലെയും പി ബ്ലോക്ക് എലിമെന്റ്സില് that is avade S2 electrons are reluctant to take part in chemical reaction. They act as an inert pair, that is known as inert pair effect. അതുകൊണ്ട് തന്നെ ബോറോൺ ഫാമിലിയിലെ ഏറ്റവും അവസാനം വരുന്ന ബോറോൺ അലുമിനിയം ഗാലിയം കഴിഞ്ഞ് ഇന്ത്യത്തിനും താലിയത്തിനും +1 ഓക്സിഡേഷൻ സ്റ്റേറ്റ് ആണ് മോർ സ്റ്റേബിൾ, +3 ആവാം. അതുപോലെ കാർബൺ ഫാമിലിയില് കാർബൺ, സിലിക്കൺ, ജർമാനിയം, ടിൻ ആൻഡ് ലെഡിന് +2 ഓക്സിഡേഷൻ സ്റ്റേറ്റും +4 ഓക്സിഡേഷൻ സ്റ്റേറ്റും ഉണ്ട്. ലെഡിനുമുണ്ട്, ടിന്നിനുമുണ്ട്. SnCl2 +2 ഓക്സിഡേഷൻ സ്റ്റേറ്റ്, SnCl4 +4 ഓക്സിഡേഷൻ സ്റ്റേറ്റ്, PbCl2 +2 ഓക്സിഡേഷൻ സ്റ്റേറ്റ് and PbCl4 +4 oxidation state, and that is due to the inert pair effect. Avade usually the +2 oxidation state is more predominant than +4 oxidation state because of the inertness of these two electron. Appo ivide choice due to the relativistic contraction of the 6s orbitals of lead and bismuth leading to the inert pair effect. Choice B ആണ്. സിലിക്കേറ്റ്സ് എടുത്താൽ that is നമ്മുടെ സിലിക്ക SiO2 ആ SiO2 എന്ന് പറയുന്നത് that is ഓർത്തോസിലിക്കേറ്റിന്റെ പോളിമറാ. എന്താ ഓർത്തോസിലിക്കേറ്റ്? SiO4 4- ടെട്രാഹൈഡ്രൽ ആണ്. SiO4 4-. അത് സെൻട്രൽ സിലിക്കൺ ആറ്റവും 4 ഓക്സിജൻ ആറ്റം 4 കോർണർ ടെട്രാഹൈഡ്രൽ 4 കോർണറിൽ O- ആണ് ഓർത്തോസിലിക്കേറ്റ്. അതിൽ ഒരു കോർണർ ഷെയർ ചെയ്ത് കഴിഞ്ഞാൽ you will get pyrosilicate. 2 കോർണർ ഷെയർ ചെയ്ത് കഴിഞ്ഞാൽ സൈക്ലിക് സിലിക്കേറ്റും കിട്ടും, ചെയിൻ സിലിക്കേറ്റും കിട്ടും. 3 കോർണർ ഷെയർ ചെയ്താൽ ഷീറ്റ് ലൈക്ക് സിലിക്കേറ്റ് കിട്ടും. 4 കോർണറും ഷെയർ ചെയ്യുമ്പോഴാണ് സിലിക്ക കിട്ടുക. എനിവേ ഇവിടെ തന്നിരിക്കുന്നത് സൈക്ലിക് സിലിക്കേറ്റും ഉണ്ട്, അതുപോലെ ചെയിൻ സിലിക്കേറ്റും ഉണ്ട്. അപ്പൊ therefore that is Si3O9 6- having 3 tetrahedral represented as that is both A and B, that is cyclic ഉണ്ട്, chain silicate ഉണ്ട്. 80th question, which of the following has maximum number of isotope? Isotopes നമ്മൾ ഹൈഡ്രജന്റെ കേസിൽ പറഞ്ഞു, 3 ഐസോട്ടോപ്പ് പറഞ്ഞു. അതുപോലെ കാർബൺ ഉണ്ട്, കാർബൺ 12 ഉണ്ട്, കാർബൺ 14 ഉണ്ട്. ആൻഡ് ടിന്നില് 10 ഐസോട്ടോപ്സ് ഉണ്ട്. Maximum number is 14. Answer D. In buckyball, each atom is, that is fullerenes എന്ന് പറയും, Buckminster fullerenes എന്ന് പറയും. അവിടെ that is sp2 hybridized and localized molecular orbital, and that is choice D ആണ്. Unlike the other elements of its group, carbon does not form CH2 type molecule because it is non-metallic ആണ്. അപ്പൊ ഹാലജനുമായിട്ട് ചേർന്നിട്ട് അയണിക് ആയിട്ട് ഫോം ചെയ്യാൻ കഴിയില്ല. And therefore it is always tetravalent. It is non-metallic. Carbon is always tetravalent because it is non-metallic. The repeating unit of silicon is silicon. Organosilicon polymer ആണ് silicons. Water repellent ആണ് R2SiO. എന്താ അതിന്റെ ഫോർമുല? R2SiO. അപ്പൊ ചോയ്സ് ബി ആണ്, R2SiO. Consider the following statements about buckyball. That is A choice, it is also called fullerene. It is true. It is also called Buckminster fullerene. It is also true. Bucky tubes made of fullerenes are several times stronger than steel wires. It is also true. Appo answer A, B and C ആണ്, choice D ആണ്. Which of the following is an example of chain silicate? Dioxide എന്ന് പറയുന്നത് chain silicate, choice D ആണ്. In silicon dioxide നമ്മൾ പറഞ്ഞു സിലിക്ക, each silicon atom is surrounded by 4 oxygen atoms and each oxygen atom is bounded to 2 silicon atoms, and that is answer is A. അതുകൊണ്ടാണ് that is 4 കോർണർ ഷെയർ ചെയ്ത ഓർത്തോസിലിക്കേറ്റ് ആണ്. അതുകൊണ്ടാണ് SiO2 ഫോർമുല വരുന്നത്. Arrange CCl4, AlCl3, PCl5 and SiCl4 according to ease of hydrolysis. Carbon tetrachloride is easily get hydrolyzed. It is not get hydrolyzed, but silicon tetrachloride is get hydrolyzed. Why? Because carbon tetrachloride carbon there is no vacant d orbital. Water molecule nowadays attach and therefore CCl4 is not get hydrolyzed. But SiCl4 is get hydrolyzed. SiCl4 nekal elupamana phosphorus pentachloride get hydrolyzed. Adinekal elupamana that is either that is aluminum chloride. And therefore the order is CCl4 less than, SiCl4 less than, PCl5 less than, AlCl3. Choice A ആണ്. ഇനി P block elements ഉണ്ട്. നമ്മുടെ ടൈം കഴിഞ്ഞു. പെട്ടെന്ന് പറഞ്ഞു പോകാം. That is in which of the following the oxidation number of sulfur is -1? FeS2. Iron plus 2 ആണ്. അപ്പോൾ 2 sulfur minus 2. Sulfur is the -1 oxidation state. Answer B ആണ്. The property of halogen acid HFHCl SBr HI that indicate incorrect is acid strength താഴോട്ട് വരുമ്പോഴാ കൂടുക. HI greater than, SBr greater than, HCl greater than HF. അപ്പൊ choice A is wrong. അപ്പൊ ബാക്കി എല്ലാം correct ആണ്. Which of the following is the life-saving mixture of an asthma patient? A mixture of helium and oxygen. Choice A ആണ്. Conductors of Xerox machine uses selenium. Choice C ആണ്. Ammonium dichromate on heating liberates a gas. The same gas will be obtained. Ammonium dichromate heat it will decompose to give nitrogen, chromium trioxide and water. That is NH4 toy Cr2O7 give N2 gas plus Cr2O3 plus 4H2O. Chemical volcano എന്ന് പറയും. Ammonium dichromate heat ചെയ്യുമ്പോൾ ഒരുപാട് പുക വരും, നൈട്രജൻ വരുന്നു, ക്രോമിയം ട്രയോക്സൈഡ് പച്ച കളറിൽ വരുന്നു, ലാവ പോലെ, വാട്ടറും ഉണ്ട്. And that is known as chemical volcano. The question is, the same gas will be obtained by ഏത് ഗ്യാസ്? നൈട്രജൻ. അമോണിയം നൈട്രേറ്റ് ഹീറ്റ് ചെയ്താൽ നൈട്രസ് ഓക്സൈഡ് ആ കിട്ടുക. NH4NO3 ഹീറ്റ് ചെയ്താൽ നൈട്രസ് ഓക്സൈഡും വാട്ടർ. അമോണിയം നൈട്രൈറ്റ് NH4NO2 ഹീറ്റ് ചെയ്താൽ നൈട്രജൻ കിട്ടും. അപ്പൊ ചോയ്സ് ബി ആണ്. Which one of the following sequence represents the correct increasing order of bond angles given in the molecule? അവിടെ sp3 hybridized ആണ്. OF2 ല്, H2O ല്, Cl2O ല്, അതിലെല്ലാം sp3 hybridized ആണ്. പക്ഷെ ബോണ്ട് ആംഗിൾ OF2 ൽ 103 ആണ്. കാര്യം ഫ്ലൂറിൻ മോർ ഇലക്ട്രോനെഗറ്റീവ് ആയതുകൊണ്ട്. ആൻഡ് വാട്ടറില് 104.5 ഡിഗ്രി ആണ്. ആൻഡ് Cl2O ല് 111 ഡിഗ്രി ആണ്. മറ്റിടത്ത് sp2 ഹൈബ്രിഡൈസേഷൻ ClO2 ല് അത് 118 ആണ്. അപ്പൊ ഓർഡർ എങ്ങനെയാ? ദാറ്റ് ഈസ് OF2 ലെസ് ദാൻ, H2O ലെസ് ദാൻ, OCl2 ലെസ് ദാൻ ClO2. ദാറ്റ് ഈസ് ആൻസർ സി ആണ്. In the oxy acids of chlorine bond contain avade that is hypochlorous acid HClO, hypochlorous acid HClO2, chloric acid HClO3 and perchloric acid HClO4. എല്ലാത്തിലും chlorine that is sp3 hybridized ആണ്. ആ sp3 hybridized orbital അത് that is ഓക്സിജനുമായിട്ട് ഡബിൾ ബോണ്ട് ഫോം ചെയ്യുന്നത് ഓക്സിജന്റെ p ഓർബിറ്റലും ഇവിടെ എക്സൈറ്റേഷൻ നടന്ന ഡി ഓർബിറ്റലുമായിട്ടാണ്. അപ്പൊ p പൈ d പൈ ബോണ്ടിങ് ആണ് ഫോം ചെയ്യുക. ആൻസർ ബി ആണ്. Which of the following represent noble gas configuration? S2p6 മാത്രം മതി. അപ്പൊ ചോയ്സ് എ ആണ്. That is valency shell S2p6. ചോയ്സ് എ ആണ്. In which of the following sequence of a reaction the gases A, B, C, D are respectively? മാംഗനീസ് ഡയോക്സൈഡ് HCl കൂടെ ചേർന്ന് ക്ലോറിന്റെ മെത്തേഡ് ഓഫ് പ്രിപ്പറേഷൻ ആണ്. MnO2 plus 4HCl give Cl2 plus MnCl4 plus 2H2O. അപ്പൊ എ എന്ന് പറയുന്ന ക്ലോറിൻ ഗ്യാസ് ആണ്. ഇനി A plus the chlorine plus fluorine, that is, it will give ClF3. That is chlorine trifluoride form ചെയ്യും T shape ഉള്ള. അപ്പൊ B എന്ന് പറയുന്നത് ClF3 ആണ്. ആ ClF3യും യുറേനിയം കൂടെ ചേർന്ന് യുറേനിയം ഹെക്സാഫ്ലൂറൈഡ് ഫോം ചെയ്യുമ്പോൾ ClF ഫോം ചെയ്യും. അപ്പൊ C എന്ന് പറയുന്ന യുറേനിയം ഹെക്സാഫ്ലൂറൈഡും ദാറ്റ് ഈസ് D എന്ന് പറയുന്ന ClF. അപ്പൊ ചോയ്സ് B ആണ്. All the 4 sigma bonds in perchlorate ion are sp3p bond. Perchlorate le sp3 orbital, chlorine sp3 hybridized orbital, oxygen p orbital കൂടിയാണ് bond form ചെയ്യുക. Answer B ആണ്. Ammonia is used in detection of cupric ion because aqueous solution of ammonia react with cupric ion to form deep blue colored complex. Choice A ആണ്. ഇതാണ് ഹൈഡ്രജൻ S block and P block elements. അപ്പൊ ഇത് നിങ്ങൾ വായിക്കുക. ഇനോർഗാനിക് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ വായിച്ച് കാണാതെ പഠിക്കുക എന്നുള്ളത് മാത്രമേ മാർഗമുള്ളൂ. ഫിസിക്കൽ പോലെയോ ഒന്നും ചെയ്ത് നമുക്ക് ചെയ്യാൻ കഴിയില്ല. അറിയാമെങ്കിൽ അറിയാം, പക്ഷെ ഏറ്റവും എളുപ്പം മാർക്ക് കിട്ടാൻ കഴിയുന്നത് ഇനോർഗാനിക് ആണ്. ഉറപ്പായിട്ടും 1/3 of the question will be from inorganic. അപ്പൊ ഇനോർഗാനിക് പോർഷൻസ് വിടാതിരിക്കുക. ഓക്കെ, താങ്ക് യു വെരി മച്ച്. ഇനി നാളെ D and F ബ്ലോക്ക് കൂടെ കഴിയുമ്പോൾ ഇനോർഗാനിക് തീരും. ഓക്കെ, താങ്ക് യു വെരി മച്ച്.
Thank you, sir.
Thank you, sir.
Okay.